So now, dear student, after completing the theoretical part of projectile motion, let's calculate the sums of the topic projectile motion. First of all, from the textbook. Actually, in textbook, total 7 sums are given. Out of 7, 5 sums is present in the exercise and 2 sums is from the illustrations. So total 7 examples related to projectile motions first we calculate, and after that few another examples for the practice purpose, few another concept related to projectile motion also I'll explain. So this sum is actually sum number 16 from the exercise. Question is, a cricketer can throw a ball to maximum horizontal distance 100 meter. A cricketer can throw the ball maximum 100 meter far. It means that maximum range is given to us. Definitely in the theoretical part we understand that object gains the maximum range agar if it is thrown at an angle 45 degree. And equation of maximum range also we know that maximum range equation is V0 square by G. So maximum range is given 100 meter. V0 square as it is, G as it is. So V0 square is equals to 100 G. So V0 is equals to 10 root G. It means that a cricketer can throw a ball maximum horizontal distance 100 meter. It means that it should be thrown with this velocity 10 root G. Now how much high above the ground can the cricketer throw the same ball? Agar that cricketer throw the ball in vertically upward direction, then it goes maximum up to which height? That cricketer throw a ball, again in a very simple way, a cricketer can throw a ball with this velocity at an angle 45 degree, then it goes maximum up to 100 meter far. Agar the same cricketer throw the ball with the same velocity 10 root G, but this time in a vertically upward direction, then it goes maximum up to which height is the question. Now if you remember the equation of maximum height, so regular formula is V0 square sin square theta upon 2G. But that cricketer throw the ball in a vertically upward direction means at an angle 90 degree. Agar if cricketer throw the ball at an angle 45 degree, then it goes maximum up to distance, maximum range is 100 meter. With the same speed, agar that cricketer throw the ball in vertically upward direction means at an angle 90 degree. Then it goes maximum at which height is the question. Okay, so put theta 90 degree, so V0 square upon 2G is left because sin 90 is 1, so sin square 90 is also 1. Okay, now V0 square, value of V0 square is 100G upon 2G, G cut, answer will be 50 meter. 50 meter is the answer. So final conclusion of this example is, if cricketer throw the ball at an angle 45 degree with velocity 10 root G, then it goes maximum up to 100 meter. But the same cricketer throw the same ball with the same speed, but this time in vertically upward direction, then it goes how much high? The answer is, then it goes up to height 50 meter. Okay, so this is the exercise sum number 16. So now after exercise sum number 16, let's calculate exercise sum number 15. Is also related to projectile motion. Question is, the ceiling of long hall is 25 meter high. Ceiling in the hall is 25 meter high. For example, suppose this is a very long hall, and in this hall the ceiling is 25 meter high. Let's write capital H, 25 meter. So in this long hall, ceiling of the hall is 25 meter high. Now what is the horizontal distance that a ball thrown with the speed 40 meter per second can go without hitting the ceiling of the hall. Suppose ball is thrown from here. That ball, suppose actually not hits the ceiling, but just pass through the ceiling and finally falls down. So we can say that the maximum height attained by the ball is considered at 25 meter. Remember, actually ball is not hit the ceiling, just pass through the ceiling and falls down on the again earth. So question is, what is the horizontal distance the ball travel? They ask us to find range. Range will be what? And one more information, the ball is thrown with what speed? 40 meter per second is the initial velocity, 40 meter per second. So in short, ball is thrown at what angle is not given, but ball is thrown with the speed 40 meter per second, and consider that it gains the maximum height 25 meter. How far it goes? What is the horizontal distance covered by the ball is the question. So let's first of all use the formula of maximum height. We know the maximum height formula is V0 square sine square theta upon 2g. Maximum height, let's put 25. V0 square means 40 square. Square of 40 is 1600. Sine square theta upon 2g 9.8. So sine square theta is equals to this 2 and 9.8 multiplied with the 25. 25 into 2 into 9.8 divided by 1600. So dear student, if you simplify all this, the answer will be 0.30625. It's a sine square theta. So only sine theta, it's in a square root of this value, and remember, calculate yourself. Square root of this value is 0.5534. Now in a natural sine, in a log table, you have to use the log table book. In a natural sine, 0.5534, for this value of sine function, what is the angle you can determine from the natural sine? Here I'll put the answer. Theta will be 33.6 degree. It means that agar the ball is thrown with this speed 40 meter per second, gains the maximum height 25 meter, it means it should be thrown at an angle 33.6 degree. Now question is how far it goes. They ask us to find range actually. So let's put the formula of range. Range formula is V0 square sine 2 theta upon g. Okay, again V0 40, square of V0 is 1600 into sine 2 theta is 33.6 degree, g is 9.8. So finally 1600 into sine 33.6 to the 67.2 degree, 9.8. Again you have to use the natural sine log table book, and in that log table book, for this value of angle 67.2 degree, what is the value of sine? You have to observe from the log table. I'll directly right now put the value of sine 67.2 degree is 0.922 upon 9.8. So finally approx answer will be 150 meter is the range. It means that the ball will cover horizontal distance 150 meter. Agar ball is thrown with the speed 40 meter per second at an angle 33.6 degree, then the range, total horizontal distance covered by the ball will be 150 meter is the answer of this question. So now dear student, let's move on. Exercise sum number 32 related to also projectile motion. In that sum, they ask us to derive two equations. There are two questions in that example, A and B, but this is only A. So let's understand what they ask. Exercise sum number 32, last sum of this chapter. Show that means they ask us to prove for projectile motion the angle between velocity and x-axis, angle between velocity and x-axis, between these two, as a function of time is given by this equation. We would like to derive this equation. Theta is the angle between velocity and x-axis, and that angle we would like to prove is this one. Okay, so let's understand with the help of diagram. It's very easy to prove. Okay, suppose this is y and x axis. We all know now the projectile motion. This is the projectile motion. Object is thrown from here with an initial velocity v0. We know that initial velocity has two components, v0x and v0y. X component of initial velocity v0 cos theta, y component of initial velocity v0 sin theta. After some time, suppose object reach here. Here its velocity is in the direction of tangent. Now this velocity, angle of this velocity vector with x-axis is suppose theta. We know that this velocity vector has two components. This is the vx horizontal velocity, this is vy. Okay, now question is, for projectile, angle between velocity and x-axis. So, say initial velocity is not written, only velocity is written. So, let's assume that this is the velocity and this is x-axis. So, angle between velocity and x-axis, theta, we would like to derive this equation. Okay, we can imagine one triangle. Look at here. In this triangle, from the figure, in this triangle, tan theta is equals to tan theta. We know that tan theta is equals to opposite side upon adjacent side. Opposite side is equals to Vy and adjacent side is equals to Vx. Now tan theta is equals to, now please dear student, try to recall the equation of vertical and horizontal velocity. We already derived in the theoretical part. Horizontal velocity is v0 cos theta. Vertical velocity is v0 sin theta minus gt. So tan theta is equals to, now dear student, just observe v0 sin theta is the initial velocity, y component of initial velocity minus gt as it is. v0 cos theta, look at that, it's an x component of initial velocity v0x. So finally theta is equals to tan inverse v0y minus gt upon v0x. Hence it's proved. They ask us to derive this equation and is proved. It's very easy one. Now this is the question number 32a. Now we calculate question number 32, exercise sum number 32, but B. In B also they ask us to derive one formula. Let's see which formula that ask us to derive in B. So this is the B1, 32, exercise sum number 32 and question number B. Also, as I said earlier, they ask us to prove an equation. Show that means prove that projection angle theta 0 means angle at which you throw the object here, theta 0, for the projectile launched from the origin, that angle of projection is given by this equation in terms of maximum height and range. Okay, let's derive this equation, dear student. Look at the proof. Okay, h is the maximum height and r is the range. Let's take the ratio of maximum height and range. Let's see what's happened. First of all, we have to put the formulas. For that is most important thing, most necessary thing, that you should remember the formula of maximum height and range. The formula of maximum height is v0 square sin square theta upon 2g. And range formula is v0 square sin 2 theta upon g. These are the formula of maximum height and range. Here angle of projection is theta 0, so I'll just change, instead of theta I'll write theta 0. Okay. Now simplify, v0 square cancel, 1 g cancel with this g. Now what is remaining now left is, Here sine square theta 0, sine square theta 0 divide by 2 is remaining, and here divide by sine 2 theta 0, sine 2 theta 0. Okay, so h upon r is equals to, here sine square means sine theta into sine theta, that is sine square theta, upon 2 as it is. Now try to recall this mathematical formula. I said that you have to accept sine 2 theta means 2 sine theta cos theta. Okay, so again this sine theta will be cancelled, and here sine upon cos is tan theta, sine upon cos tan theta, divide by 2 to the 4 is remaining. So finally h by r is equals to tan theta by 4. Okay, h by r is equals to tan theta by 4. So from this equation tan theta 0 is equals to 4h upon r, 4 will go in the multiplication of h. Theta 0, finally theta 0 is equals to tan inverse 4h upon r. Hence is proved that we derive this equation, and according to my opinion you should also remember this equation, because what happens sometimes that sometimes in some of the MCQ object is thrown with what velocity at what angle is not mentioned. Agar if it is given to you, okay, object is thrown, it gains the maximum height 10 meter and range will be 40 meter, find the angle of projection. So through this equation we can directly give, within a one step of simplification we can directly give the answer. So this is also the important formula that we derived. Okay, so this is the illustration number 9 related to projectile motion. Last illustration present in the textbook. Question is, a cricket ball is thrown with the speed 28 meter per second. So we have initial velocity 28 meter per second at an angle 30 degree with the horizontal. Okay, angle of projection is also given. Calculate, okay, first one is maximum height. They ask us to calculate maximum height. Remember we have two information. Look at the solution. Initial velocity, that is 28 meter per second, as well as angle of projection is 30 degree. We have two information. From this two information, the first question is maximum height, h. So try to recall the formula of maximum height. The formula is V0 square sine square theta upon 2g. Let's put the value. V0 28 square sine square theta is 30 degree, 2g is 9.8 is equals to 28 into 28, square of 28. Dear student, value of sine 30 is 1/2, means 0.5, and that is a square. So it's in a 0.25, square of 0.5 is 0.25, 2 into 9.8. If you simplify, the answer will be 10 meter. So this is the maximum height attained by the ball. Second question, let's read first of all B. Time taken by the ball to return to the same level. It means they ask us to find time to flight, total time it will take for the motion. So B is time to flight. Okay, the formula of time to flight is 2v0 sine theta upon g. Agar if you are unable to remember the formula, it means you are unable to get the answer. So formula is most important. You should remember all the formula. Okay, 2v0 28, theta 30 and sine 30 is 0.5, g is 9.8. If you simplify, the answer will be approx 2.9 second. So this is the time to flight. 2.9 second is the total time taken by the ball to return on the ground at the same level. Now question number C. Let's read first of all. The distance from the thrower to the point where the ball returns to the same level, means they ask us to find range. Look at here. This is the point of thrown point, and when it returns at the same level, what is the total distance traveled by the ball, horizontal distance? That means they ask us to find range, and formula of range is V0 square sine 2 theta upon G. Okay, V0 square means 28 into 28, theta will be 30, 30 to the 60, sine 60 degree upon G means 9.8. So 28 into 28 into sine 60, value of sine 60 is root 3 by 2, divide by already 9.8 is there, and now simplify yourself. I'll write the answer. 69 meter is the range. Means ke in this entire sum, ball is thrown with velocity 28 meter per second at an angle 30 degree. It will get maximum height of 10 meter. Total time to complete the motion is 2.9 seconds, and total horizontal distance range will be 69 meter. So this is the illustration number 9 of the textbook. So dear student, still 2 or 3 more sums are remaining to calculate from the textbook related to projectile motion. But before move forward in doing the sums, let's understand some more important facts related to projectile motion. Actually is not mentioned anywhere in our textbook, so it's an important to observe, important to understand. Please look at here very carefully. Some important information about projectile motion. Information number 1. Okay, so we all know now that projectile motion, the path is parabolic type. Path is parabolic type. So suppose object is thrown from here with some initial velocity V0. So in this diagram, initial velocity has 2 components. This is the x component of initial velocity. This is the y component of initial velocity. Suppose if it is given initial velocity V0 is 2i caret plus 3j caret. So it means ke x component of initial velocity is 2 and y component of initial velocity is 3. 2i caret plus 3j caret. So question is, what will be the final velocity? Will be what? Means ke when the object falls on the ground, at that time it falls with what final velocity? Okay. So remember, at this point velocity is in the direction of tangent, has 2 component, x component and y component. So already in the beginning part we studied that during the projectile motion horizontal velocities remains constant. It means ke initial horizontal velocity is 2, then final horizontal velocity is also 2 meter per second. Whereas initial vertical velocity is 3 meter per second, final vertical velocity is minus 3 meter per second, exactly because of in opposite direction. So answer, if initial velocity is 2i caret plus 3j caret, then the final velocity is 2i caret minus 3j caret. Minus sign because of that final velocity, y component is in downward direction. Whatever the initial y component is the final y component. So remember this information clearly. Another information that I want to give you, for that you have to assume one situation. Suppose one person is standing here at A point. Imagine the situation, it's very important. One person is standing here at A point and he has a ball in his hand. He throws the ball at some angle with some velocity V0. He throws the ball at some angle with some velocity. Immediately after that, he runs with velocity V, tries to catch the ball, It's like that. I'll throw the ball and immediately after that I'll run to catch the ball. So here V is the velocity of boy and V0 is the initial velocity of the ball which is thrown at an angle theta. I hope you understand the situation. Now question is, can he catch the ball or not? he is able to catch the ball or not? I'll give you the answer. If one condition is satisfied, then he is able to catch the ball, otherwise not. Remember, this initial velocity has two components. This is the x component of initial velocity, which is v0 cos theta, and this is y component of initial velocity, v0 sin theta. Again, I'll repeat the situation. A boy is standing at A point, throws the ball with velocity v0 at an angle theta. Immediately after that, he runs with the velocity v to catch the ball. He is able to catch the ball or not? To get the answer, remember, if horizontal velocity of ball and horizontal velocity of boy, agar these two velocities are same, then at whatever the place ball falls down, that boy will definitely reach at this point and he is able to catch the ball, otherwise not. It means if velocity of boy should be equals to v0 cos theta, horizontal velocity of ball and horizontal velocity of boy, agar these two velocities are same, then and then only he is able to catch the ball, otherwise not. So this is also the interesting information about the projectile motion. So remember this information. Now let's move forward in calculating the sum from the textbook. So now next one is illustration number 8 from the textbook, illustration number 8. Question is, a hiker stands on the edge of a cliff. That cliff is 490 meters above the ground. For example, suppose this is a ground and consider this is a cliff, and height means y displacement is 490 meter. So one hiker is standing over here at a height 490 meter from the ground, above the ground, and throws a stone. Okay, he has a stone, imagine, in his hand, and he throws the stone. In which way? He throws the stone horizontally with initial velocity 15 meter per second. Okay, from here he throws the ball horizontally. Okay, with initial velocity, that is the x component of initial velocity, that is 15 meter per second. So remember here, y component of initial velocity is 0. Initial horizontal velocity is 15 meter per second. Okay, he throws the stone horizontally with this speed. The question is, find the time taken by the stone to reach the ground. Means stone will take how much time to reach at the ground is the first question. And also they ask us to find speed with which it hits the ground, final velocity, final velocity. Okay, just in the previous information I'll mention that final velocity has two components, Vx and Vy. And during the projectile motion, x component remains constant. Okay, it's a later thing. First of all, let's find stone will take how much time to reach at the ground. One logical thing is that, think logically. Initially stone is here at what height? 490 meter. Finally stone falls on the ground, means at 0 height. So what will be the y displacement of the stone? Y displacement of the stone is 490 meter. So let's use the formula of y displacement. Y displacement is v0 sin theta t minus half gt square. This is the formula of the y displacement. Okay. Now y displacement is 490 meter is equals to, okay, v0 sin theta. We know that in a projectile motion, v0x and v0y, v0x, v0 cos theta, v0y, v0 sin theta are the initial component of the velocity. But as it is observed from the diagram that y component of initial velocity v0 sin theta is 0. This is 0 into t minus 1/2 g 9.8 t square. Okay, Actually, we should have to write minus 490 because the downward displacement is negative, minus 490. So minus 490 is equals to, this term is 0, minus 9.8 by 2 t square. Negative negative sign cancel from both the side. 490 2s are 980 is equals to 9.8 t square. So t square is equals to 980 upon 9.8. So t square is equals to 100, t is equals to 10 second. So answer is, it will take 10 second to reach at the ground. The stone will take 10 second to reach at the ground. Now next question, we would like to find with what velocity the stone strike hits the ground. So that is the final velocity, has two component Vx and Vy. As we know that horizontal velocity, initial horizontal velocity is 15, so final horizontal velocity is also 15 because horizontal velocity remains constant. Let's find the vertical velocity. Vy, equation of vertical velocity is V0y, V0 sin theta minus gt, where the first term is 0 because initial vertical velocity is 0, minus g is 9.8, t is 10 second, it's in a minus 98 meter per second. That is the minus, because of this is downward direction, so minus 98 meter per second is the final vertical velocity, and final horizontal velocity is 15, final vertical velocity is minus 98. So what will be the final velocity? The final velocity means Vx and Vy are the components of the final velocity. So according to the previous rule, square root of the square of the sum of the component gives the final velocity. Under root of 15 square plus minus 98 square. Dear student, 15 square is 225, and square of 98 is 9604. Addition of this two, doing yourself, it's in a 9829. It's in a final velocity, and square root of this value will be 99 meter per second. So this is the second answer. With a velocity 99 meter per second, the stone hits the ground and it will take 10 seconds to reach at the ground.